Hello everyone. We have discussed regarding acids and bases. We have discussed what is acid. We have defined what is acid also. There were three definitions as you can remember. Now we have discussed some of the properties of acids also in the last video. Today, as we know, the chemistry will only be learned, especially this part, the acids and bases, in the lab basically. In the other years, normally we used to do a lot of experiments, but unfortunately, due to this reason, we could not do those. So what I have planned is let us do some virtual lab experiments. Let me show you some of the lab experiments, obviously through the video itself, through animations. Real life experience can only be done once we get back to the normal life into the schools. But you see this carefully. I'm going to narrate what am I doing, and there you will understand how the acid will actually behave. So the properties of acid can be reanalyzed with the form of these animated videos, with my narration of course. So carefully see, this is a kind of virtual lab type of experiment, and there you will understand how the acids or the bases will behave. So we will do three experiments today, three very special one. See them one by one. So we will do our first experiment today with the reactivity of metals with acids. We know certain metals with acids will have different reactivity based on the reactivity series. So here we have taken few metals such as magnesium, aluminium, zinc and copper. So we are starting with magnesium. We are putting it in hydrochloric acid, and let us check the temperature. You can see the temperature is rising. You can see thermometer is kept over there. It is 40 degree now, 41, 42 like this. The temperature kept on increasing. So how much it is? 54 now, 57, 50, you can say 60 degree it is up to. Next metal, let us start with aluminium. So our earlier metal was gone up to 60 degree. Let us see what aluminium does. So we have added aluminium. So the solution where aluminium makes the water rather, see it is comparatively quickly increasing. It is already 48, 50 now. How much it can go? 60 already. It is increasing more. You can see 67, 60, 70 almost, 75, 78, and it is becoming 80 degree almost. So it is becoming blackish also. Next, zinc. So let us see what zinc will do. Here also the temperature is increasing. Notice the pace. We have seen compared to magnesium, aluminium reacts more vigorously with HCl because of its higher reactivity. Now see here it is 34 degree. Don't you think the speed in which this metal reacts is comparatively lesser? Now copper. What it will do? Hardly any reaction. So copper hardly reacts with the acid. It could not displace the hydrogen as we know because it is situated lower at the reactivity series. So from all these cases we have understood that different metals behave differently with different acids, and we have done the experiment to prove that also. The metals which can displace hydrogen more vigorously will be reacting more quickly, of course. So here it is written metal plus dilute acid gives rise to salt plus hydrogen. Gold, silver do not react with metals because they are much more inactive. Write down all these things. Now let us see what happens when acid reacts with metal carbonates. So let us see very carefully. There are some very common mineral acids which we are going to use. So for that we all know that the most common acids present in our lab is which is mineral also, that those are hydrochloric acid, sulfuric acid and nitric acid. So here it is hydrochloric, sulfuric and nitric acid. Now why these are called acids we all know, we have discussed. It can give rise to H plus ion in the medium. Now see, it gives rise to Cl minus, it gives rise to SO4 2 minus, and it gives rise to NO3 minus. The anions are different which will be generated. Now, if we take little bit of metal carbonates into the acids, what happens is the bubbles will come out, a odorless gas will come out, and that is nothing but the presence of carbon dioxide. So when HCl reacts with calcium carbonate, it gives rise to calcium chloride, carbon dioxide and water. That is why geologist adds little bit of HCl in the stone. They observe whether the carbon dioxide is coming out or not. If it is, then it is surely carbonate. We know the neutralization reaction at the same point of time. We know if acid reacts with base, it gives rise to salt and water. So obviously, let us see what metal carbonate does when it reacts with acid. So if we take acid plus metal carbonate, it also gives rise to salt and water. So although metal carbonates are insoluble, but it is supposed to be basic. Now carbon dioxide, when it combines with water, it gives rise to the carbonic acid, which is nothing but the rainwater, or the acid rain also we can call, because the carbonic acid also gives rise to H plus ions. This carbonic acid is the responsible for the carbon dioxide that is coming out from the cold drinks or the soda water. If rainwater mixed up with calcium carbonates, what happens is it forms calcium hydrogen carbonate, calcium bicarbonate, and slowly you can see all those pillars and monuments which are prepared by these insoluble materials, they actually get corroded. So that is how the acid reacts with metal carbonates. Now there is a very good reaction to see. If we take metal carbonates in acid in this test tube, what happens is the carbon dioxide gas will be generated, and through this tube it will come onto the right hand side. See, these bubbles are coming out. So it forms the lime water which is kept on the right hand side into a milky one. So it forms calcium carbonate and water over there. Our next experiment today is the indicator action. We are going to use indicator in strip form. So this is called the litmus paper. They are basically of two types, blue and red. So what they will do, these are common acid base indicators. They can change its color when it is added to acid or base. We are going to discuss regarding indicators in details in the next video, but this is a virtual lab. So here we are going to discuss only about the litmus paper action on the acidic solution and the basic solution. So let us take one beaker. Let us fill it up with acidic solution. Let us fill it up. Now let us dip one litmus paper. So one blue litmus paper is dipped into this acidic solution. Will there be any change? Let us see carefully. Is there any change? Not yet. We will see the part which is dipped is slowly becoming red. You can see here. Now since it is becoming red, what does it mean? That means the litmus paper, blue litmus paper in acidic solution converts into red. Similarly, if we take a basic solution, let us take another solution, basic one. Here it is. So this is a basic solution. Here we are going to dip the red litmus paper. Will there be any change? Well, definitely the red litmus paper will be converting itself into blue, which you can see right now. So it is converting into blue. That means in a basic medium, the red litmus paper converts into blue. Now red litmus paper and blue litmus paper are good acid base indicators, but there is a universal pH paper. There is another type of indicator which is called the universal pH paper. What it can do is, initially the same paper can be used to detect the acidity or the basicity. So let's see how it works. It is slightly different from the blue or red litmus paper. Let us see. So we will take any solution and we will find it out whether the given solution is basic or acidic. So here we have taken a solution, a basic solution, say for an example. Now we are dipping the universal indicator. It is like this color, yellowish. Yellow to orange, you can say. If you see it in real life, slight orange tinge is there. It is basically yellowish, this kind of yellow color which you can see right now. Now with time, when it is dipped in basic solution, the color will change. What kind of change? Yes, it will turn like this. Violet color, you can say, purple rather. Now how will we know that what kind of nature it is having? From this color strip you can match. See the alkaline region, it is matching with that region only, and if we match the exact color, it is coming out to be this one, 12. So its pH is actually 12. What is pH? Regarding that, in the next video we will have discussion, but the neutral pH is 7, and from 8 to 14, from 7 to 14 rather, it is basic. So we are getting a basic nature. The solution change color of the solution which you can see is the basic one, and accordingly the pH paper is also showing that it is a basic solution. So 0 to 7 was acidic, but it is showing the basic one. So that is how we can detect.